See this building? No windows, no people, and it's eating as much electricity as 100,000 homes. The smartest machines we have ever built just smashed into the dumbest possible wall. And it isn't a chip or a line of code. It's a steel box the size of a truck that takes 2.5 years to show up. Everybody's been staring at the brains of AI. Almost nobody's been watching the plug. This is the war AI can't code its way out of. And the strangest part? The bill is quietly landing in your mailbox, and nobody asked if that was okay.
Chapter 1. The building that eats a city. Let's start with that building. It's a data center, a windowless warehouse, wall-to-wall with humming computers, the physical home of what we cutely call the cloud. A big one quietly pulls the power of 100,000 homes. A hyperscale campus? Closer to 2 million, a small city that never sleeps, never turns a light off, and shows up on the grid as if a whole new town appeared overnight. And there isn't one. There are hundreds, with hundreds more being poured right now. Here's the part that never makes the keynote. That electricity comes from the same wires, the same power plants that feed your house. And it's thirsty in another way too. The big ones can drink millions of gallons of water a day just to stay cool, often in places already running dry. So when AI gets hungry, you're at the same table, passing the same plate. Bon appetit. Chapter 2. Just how hungry is it?
How hungry are we talking?
Okay, buckle up. In 2024, the world's data centers burned about 415 terawatt hours of electricity. By 2030, that roughly doubles to nearly 950. That is about 3% of all the electricity on planet Earth, more than the entire country of Japan uses in a year. And it is not slowing down. Utilities across America are now planning to spend something like $1.4 trillion wiring up the grid just to keep pace. The accelerant isn't the internet. We've had that for decades. It's AI, training the models, then answering billions of questions a day. The industry even has a name for the race now: speed to power, because whoever can plug in fastest wins. The line on this graph doesn't curve gently upward. It goes vertical.
Chapter 3.
The trap hiding in plain sight.
Now here's where your brain gets played.
Ask an AI one question, and that single answer uses about 1/3 of a watt hour. That's the company's own number. Roughly the same as one Google search. Tiny. So if every query is that cheap, why is the total exploding? Welcome to the trap. It's an old one, named after a man who spotted it with coal back in the 1800s. Jevons paradox. Make something cheaper and easier, and we don't use less of it, we use wildly more. Cheap AI doesn't shrink the bill. It means every email gets an AI summary, every search gets an AI answer, every app bolts on a chatbot nobody asked for. 1 billion tiny sips all day from everyone, until they become an ocean. Efficiency isn't the rescue, it's the on-ramp. Chapter 4. The wall it can't code around.
So just build more power plants, right?
Oh, sweet child. Here is the wall AI cannot think its way around. To move serious electricity, you need a transformer, a giant steel and copper box that steps the power up and down. Today, ordering one means waiting about 128 weeks, 2.5 years. A big gas turbine? There's a 5 to 7 year backlog. Roughly 80 gigawatts of orders against factory lines that build maybe 30 a year. Just plugging into the grid at all? A 4 to 7 year queue. And a frightening amount of it leans on a single factory in America that still makes the special electrical steel. So the trillion-dollar genius slams into a brick wall built of copper, steel, and 19th century supply chains. And there is no prompt for, make the transformer arrive faster. You can summon a poem in a second. You cannot summon a substation. The intelligence stops dead at the fence. Chapter 5. Follow it to your mailbox. So who pays while everyone waits? Follow the wire to your mailbox. In America's biggest grid, they call it PJM, 67 million people across 13 states, the yearly auction that keeps the lights on just jumped 174%. About $9.3 billion of that increase traces straight to data center demand, and it gets smeared across everyone's bill, whether you have ever touched an AI or not. The price grid operators pay for backup power went up roughly 9 times over, slamming into the legal ceiling 2 years running. One honest estimate has it adding up to $70 a month over time to a normal household. Now, full honesty, because we're not a tabloid, data centers are a big reason your bill is up about 42% in 5 years. They're not the only reason. Aging wires, pricier copper, and green energy mandates all pitched in. But a big reason is still you, quietly co-signing a loan for somebody else's gold rush. Chapter 6. And people noticed. And people noticed. Of course they noticed. This is where it gets loud. People did the math on their own bills, and they are not having it. States are fighting back. Virginia, Ohio, and Oregon are writing rules that carve data centers into their own special rate class. A polite way of saying, you caused the cost, you pay it, not grandma on a fixed income. Senators have started sponsoring bills with exactly that idea. Make big tech foot its own power bill instead of socializing it onto everyone. And towns are turning up at zoning meetings, packed to the back wall, telling the trillion-dollar companies, you want a city's worth of electricity? Fine. Build your own power plant. Don't bolt it onto ours and mail us the difference. The fight was never really about whether AI is good or bad. It's about a very old question. When the boom needs power, who eats the cost? And who just gets the invoice? Chapter 7. Skip the line. And big tech's answer to that 4 to 7 year line? Skip the line entirely. If the public grid is too slow, build your own. So they're restarting a nuclear plant. Yes, that one, 3 Mile Island, and wiring it straight into a data center. They're pre-ordering fleets of tiny next-generation reactors, the small modular kind that barely exist at scale yet. And when even that's too slow, they bolt natural gas turbines right next to the building, behind the meter, off the public grid, and stand them up in about 18 months. Funny thing about all those glossy net zero carbon neutral pledges, when the electrons are needed right now, this quarter, the quiet backup plan tends to run on gas. The climate promise is for the press release. The gas turbine is for the deadline. Chapter 8. The other gold rush. Meanwhile, on the other side of the planet, while America argues about transformers and queues, China is just pouring concrete. In one single year, it added 543 gigawatts of new power capacity, more than the United States has built in its entire history, and then stacked over 400 more gigawatts of wind and solar on top of that. In its cheapest provinces, power reportedly sells for around 5 cents a kilowatt hour, against 25 to 40 cents in parts of America. They are not smarter. They are just faster at building the boring stuff. The wires, the turbines, the plants. So here's the real question this whole war comes down to. Everyone is obsessed with who has the smartest model. But if the smartest model can't get plugged in, and the other side has rivers of cheap electricity ready to go, then maybe the AI race was never really about the cleverest algorithm at all. Maybe it's won by the cheapest electron. So here's the whole thing in one breath. AI keeps getting more efficient and hungrier than ever, because that is always how this goes. The wall in front of it isn't a smarter chip. It's steel, copper, and turbines that take years to build. The giants are racing to feed the machine, restarting reactors, bolting on gas, jumping the queue, and the cost of all of it is quietly landing on your kitchen table. The smartest technology ever built, throttled by a 2.5-year steel box and paid for, in part, by you. So let me leave you with one honest question for the comments. Should the companies cashing in on AI pay for their own power? Or is it fair that it just lands on everyone's bill? Tell me, I'll read them. I'm a donkey on the internet. See ya.